Have you ever needed to draw a 2D shape in Godot and needed to rotate it? It's pretty easy in most cases. That's what we thought when we were first writing our Godot 2D orbit simulation code. But what if you needed to use the draw arc function like we do in our orbit simulations? The Godot drawing functions are fast and efficient and work great. We use the draw arc method to draw an ellipse by mirroring and combining two arcs. But we ran into a problem with drawing the arcs and the ellipses at rotated angles. More specifically, we needed to rotate the ellipses around a specific pivot point. Here's why it was a problem and how we got around it. First, some details on why it was a problem. If you'd rather jump straight to how we solve it, you can use the chapter markers in the video timeline. First, let's look at the basic drawing functions in Godot. Each of these has a default position from which the shape is drawn, marked with red dots. And now the problematic draw arc shape. This drawing function uses a different method internally, the draw polyline function. For more information, you can check out the Godot documentation or even dive into the Godot source code to see what the draw polyline function does. To make an ellipse, we use the scaling capability of the drawSet transform function and combine two mirrored arcs into a single ellipse. Make sure you reset the transform back to the default transform after you've used it each time. You'll see in the script that we reset the scale, the rotation, and the position between each drawing using the exact same boilerplate code. Seems okay to me, so what's the problem? No, we're getting there. The drawSet transform method can also be used to rotate objects. By default, the red dot position is where the rotation pivot happens. Here's how it works for the simple shapes rotating around the default pivot. But see what happens when we use this method to rotate our scaled arc and ellipses? The root of the problem is how we used the drawSet transform's scale parameter while drawing the two arcs of the ellipse. Notice that an ellipse that is rotated should not have the same x and y scale ratio as the initial ellipse, and the drawing engine does not account for that. So rotating the arcs moves the perimeter of the ellipse and does not actually rotate the ellipse itself. Looks neat, but that's not what we needed. To complicate things, the drawSet transform method can also be used to change that pivot point around which the rotation is centered. It works great for rotating many of the simple drawing shapes around a point other than the default. In these examples, the yellow dot is the old default pivot point, and the red dot is the new offset pivot point that we control. But see what happens when we apply the same technique to arcs and the double arc ellipse? We get the perimeter shifting instead of the rotation we want. It's rotating around the correct pivot, but it is maintaining the wrong x and y scale ratio of the original ellipse. Again, this looks interesting, but it's not what we're going for. There were a few options, but since we're using Godot, we decided to do the Godot thing. We created an ellipse class that is essentially a node 2D scene. We could place that node into our main game or simulation, and rotate the entire node around whatever pivot point we want. While it was not ideal in our eyes, it did serve the exact purpose we needed it for, and it's great for representing Kepler orbits in 2D. Since we had full control over the drawing via a wrapping node, we also added marker dots for various important spots inside and on the ellipse. For example, the two focus points and the four outermost points have dots with different colors. This made visualizing the ellipse much easier during debugging. Now that our drawing was being done in its own node, we could rotate the node to get the effect we wanted. We can rotate the ellipse around a focus point so that it looks just like the path of an object in a Kepler orbit around a central mass. So that's how we draw elliptical orbits at an angle in Godot. We use this method for 2D orbits on rails in our simulations since their orbital paths never change. Look out for a future video where we'll show another way to draw orbits and paths that are not simple Kepler orbits and ellipses. We'll dive into the trajectory class and tackle some of the tougher hyperbolic and parabolic paths that we need to draw in the simulations. If you made it this far, you probably don't want to miss that one. Thanks for watching. Hope it was helpful.